I'm ready for part 2 of the final exam review. Again, slow this down, back it up if you need to. Kind of quickly through these. Number 1, just evaluating a function at several values. So their function x cubed plus 6x. Here, if we plug in -2, -2 cubed, 6 times -2. So be careful with the sign here. This will be -8, 12, that would be -20. Thing but with -1. Careful with the sign, that would be -1, 6, 7. 0 is pretty easy. We have 0 cubed, 6 times 0, 0. 1/2 is a little trickier. You feel free to use a calculator. 1/2, I'm going to see how I do with half. So to raise a fraction to a power, you raise the top and bottom to that power. So 1 cubed is 1, 2 cubed 8, and half of 6 is 3. We've got 3 and 1/8, or that'll be 25 over 8 is an improper fraction. 2. Piecewise function. So I'm going to call this one 1, 2, 3. 1, 2, 3. Way I can just tell you which one I'm plugging into. Do that based on the x value that you're using. So for f of -5, -5 is less than -2. I'm going to use 1. 1 times -5, 35. -2 will be the middle piece because it says x is between -2 and 5, but that includes -2 and 5. Plug in 2 there, so that'll be -2 plus 2. 0. 4 again goes with the middle one. 4 is between -2 and 5. 4 plus 2, 6. 5 again is the middle one. Have that or equal to bar there. 5 plus 2, 7. And 8 will finally be option number 3 because 8 is bigger than 5, what it tells us to do. So 8 minus 5 squared, that gives us squared, which is be able to know how to use a piecewise function. Number 3 says find the domain. Since we have a denominator here, don't want the denominator to be 0. So I know I've got to figure out what number makes that happen and leave that out of my domain. So I'll set the denominator equal to 0 and solve. Here, we don't want x to be 5. So I'm going to go from -infinity up to 5. I want to leave 5 out, so I would do a parenthesis. Now having my union symbol, pick back up right after 5, so again another parenthesis. I go all the way to 4. We're dealing with a radical. We want the domain of that function. So what I want in my domain is I want thing under the radical be bigger than or equal to 0 because I can't have negatives. So I'll set that greater than or equal to 0. Solve. Here it says I want my p-values to be greater than or equal to -5. So the smallest they can be is -5. We are including that value, have a bracket, and anything bigger than that works. I can go all the way to positive. Switch colors here since the graphs are red. use the vertical line test to determine whether the curve is a function. Okay, so vertical line test is if there's anywhere we can draw a vertical line where it touches the graph more than once, it's not a function. In this case, no matter where we draw a vertical line, it's only going to touch once, so it is a function. B is not a function because if we draw a vertical line through there, it touches more than once, so function. D again is not a function. If we draw a vertical line somewhere through there, it touches more than once, so not a function. D, no matter where we draw a vertical line, it's only going to touch it most once. When it's a my last line there's not too vertical. Switch here. Number 6, we want to know what transformations have been done to our starting function f. So here +2 on the outside, let me change back to +2 on the outside means we're going to go up 2 units. So there's 2 choices there. And +5 inside with the x. That means, remember, we kind of have to think about these backwards. So that means we're going to go left 5 units. Up 2 and 5 units to the left. That's this one. 5 units to the left. B is a similar looking function. On the outside we have -3, so that means we're going to go down 3 units. Got it down between these 2 choices. It's -7 inside with the x, means we're going to go to the right 7. So 6 right, 3 units down. That last 7. Dealing with the same types of things, but we've got some reflections possibly thrown in on this one. So +2 on the outside, we know we're going to go up 2 units. So we got it narrowed down to those 2. The minus sign out in front of our function means everything that was up is going to go down, everything that's down is going to go up. That is a reflection over the x-axis. Switching the top and bottom. That one sign up. Last one here, we know we're going to go down 2 units. So down to those 2. And this times 6 out in front of the whole thing, since that number is bigger than 1, means we're going to stretch by a factor. Here we're stretched by a factor of 6 and shifted down 2, so our third choice. And my page will load here in a second. 8, we have some function composition. We want to evaluate the expression. We're doing function composition, but we're evaluating at 0. Here, f of g of 0. If we take 0 and plug it into g, plugging it into this function, we have 5 minus 0, we get 5. F of 5, plugging in this function now, 4 times 5 minus 5. So 20 minus 5 will give us last one. Let me write it out. Go. We're going to plug 0 in 4x minus 5. We'll get -5 there, so we want g of -5. I'm going to take -5 and plug it in g. So 5 minus -5 squared, so 5 minus 25. Minus graph of a function. We want to know, is it 1 to 1? Figure that out. We're going to look at the horizontal line test. Is there anywhere we can draw a horizontal line where it touches our graph more than once? I think so. I think in there we can draw a horizontal line that touches it more than once, so it fails the horizontal line test, so no, our function is not 1. 10 is assume that f is a 1-to-1 function. Says if f of 4 equals 16, what's f inverse of 16? Well, you just need to know the inverse function, switch the x. F inverse of 16 will be 4. B says if f inverse of 50 is 25, find f of 25. Well, let's just switch, so it'll be 11 says find the inverse function of f. Remember, these are the ones where we, instead of calling it f of x, I suggested calling it y. Switch the x's and y's. X equals 6 minus 4y to the solve for y, so I'm going to subtract 6 from both sides. To divide both sides by negative 4. X minus 6 over negative 4 cubed. Get rid of that third power. You can take the cube root. Cube root of x minus 6 over negative 4. That is y, or you could also call it f inverse. Well, let's find the maximum or minimum value of the function. Well, how are we going to do that? It's quadratic, so it means we can find the vertex. Minimum or maximum will happen at the vertex. Here, negative b over 2a. Here's a. Negative b will be positive 18. 2a, so 2 times 3. 18 over 6. 3. It's going to be where our minimum or maximum occurs. That's our x coordinate. Now to get our y coordinate, we're going to take 3 and plug it into our function. We want f of 3. Numbers are a little big here. 3 times 3 squared, 18, 3, minus 140. I'm going to be a little lazy and use my calculator here. 3 times squared, 18, 3, 40, 167. We want to know, is that the minimum or the maximum? Well, I can tell you that because our leading coefficient is positive, the parabola here will open upward, so that means the vertex is a minimum value. If our parabola opened downward, we would have a maximum. Not what we got some polynomial division to do here. Seems like most of you like synthetic division, so I'll do these with synthetic. You can do both of these either way. So this one's the one I'm looking at my coefficients. So my coefficients are 2, negative 5, negative 5. Not missing any powers of x, so I don't need a placeholder. Take the opposite of that one. 2 turns into positive 2. Bring down my first number. 2 times 2 is 4. Negative 5 plus 4 is negative 1. Negative 1 times 2 is negative 2. Negative 5 minus 2 is negative 7. Wants me to put my answer in that polynomial form. So since I started with x squared, now my answer will start with just x. So 2x minus 1 plus my remainder over my divisor. For what number is this? Number 14. Same type of problem, just a little bit longer. And I'm not missing any powers of x. Coefficients are 2, 6, -3, -1. Because this is plus 4, I'll plus 4 out front. Bring down the first coefficient here. 2 times -4 is -8. 6 minus 8 is -2. -2 times -4 is +8. -3 plus 8 is 5. 5 times -4 is -20. -1 minus 20 is -21. Since I started with third power, my answer will start with the second power squared. So I have 2x squared minus 2x plus 5 plus my remainder of -1 over my divisor x plus 15. Next page load here. Here we go, number 15 says match the exponential function with its graph. I'm going to zoom out a little bit with this one. So it may be easier to start with the one that doesn't have any minus signs. So this one is going to be C. No minus signs. If we put a minus sign out in front of the whole thing, that's going to flip it upside down. X-axis reflection. So this one will be A. We put a minus sign with the X, that's a Y-axis reflection. So it's going to switch the left and the right. This one will be B. And then the last one, we've flipped upside down, we've flipped top and bottom and left and right. So this one is B. Main thing to remember there, you do have to remember the reflections, but is remember what this graph looks like. And number 16 is convert the following to logarithmic form. We're not trying to calculate anything here, we're just trying to change it to logarithm form. So our big number here is 6, so we're going to have log base 6 of, we're on the other side, 1296 equal exponent. Trying to put it in logarithm. B, we're trying to go from logarithm form to exponential form, so the base of our logarithm is 6. And that says that 6 second power is 36. Alright, that's all we have. If you have other questions or about anything, let me know.